Hey guys, what's up? Eddie Aho here with KissAnalog.com. Hey, today I have something new. I got a package from Gearbest. This is a little DSO, a little small scope. It's under 20 bucks. I think it's around $18 on sale. 17 something, I believe. So they reached out to me. It's kind of cool that they found my little channel, and I guess they were kind of impressed with the channel, and which I think that's kind of cool. And there's no strings attached. They just offered to send me this to review, and if things go well, they'll give me more stuff that I can give away to my viewers. So I think that's pretty cool too. So hey, if it helps pay for some of the stuff back here that I get, use my link. I appreciate that. I'll put the link down below. But yeah, we'll see how this thing goes. And I don't know anything about Gearbest, to be honest, so I'm hoping that they're as good as they seem. They've been great on the emails. They've given me a link, they gave me this, and they've kind of hooked me up. So far they seem to be great. No strings attached, like I said. So they said that that'd be too obvious, that they want it to be honest. Otherwise, you guys would know. And why would I want to get a $20 item and the time I spend on this YouTube stuff, it's not worth me promoting things like this that in some kind of strange way, unless it's just straight up honest. So that's the way it's going to be. So let's take a look. I mean, it can't be too bad, under 20 bucks, right? So we're going to hook it up to this little power supply back here and see what it looks like. We're going to look at the output voltage and ripples and see if we can actually see that stuff. If we can, wow, it'd be kind of cool. Instead of using a scope on a ground or something that you might be afraid of, instead of buying an expensive, even the inexpensive differential probe is expensive, this kind of be looked at as a differential probe, I guess, because you hook it up anywhere you want and it's safe to do that, I guess. I think. Don't know what the voltage ratings are on it, but at least it's isolated from your scope probes is, I guess, what I'm thinking. So hey, let's open up this box. Well, actually, honestly, I took it out of the shipping box, but I haven't opened it up yet. Alright, still sealed in the bag, so you know what, I'll bring the camera over here and we'll open it up. I hope I don't have to assemble too much. It doesn't look like it. Alright, we'll bring the camera over. Let's take a look at this thing. Okay, so let's see what Gearbest sent us. That's an interesting bubble wrap. It's like they had to smash it to get in here, I guess. Alright, let's get in this thing. I'm dangerous with these things, so careful trying to not cut my hand off here. Just some little feet to hold this up off the tabletop so we don't smush the leads down here. Looks like there's a little protective cover there. Alright, well, that's what it looks like. So we have the little BNC, and yeah, they feel reasonably nice. I mean, for how inexpensive this is, it's kind of crazy, right? It'd have to be a complete dud not to be worth, $18, I think. Now this is the 2-page manual that came with it, and here, let's just move this aside for just real quick and take a quick look at it. Basically, it just gives the layout, tells you what everything is. We're going to go over that with the unit itself. It has some operations information, and it has some tips here, some alignment tips, and how to restore factory resets. We're going to go through these steps, okay?
the probe calibration. It's interesting with the ×1 probe that we'd still have probe calibration, but there's two capacitors right here, two trim capacitors, these two green things, shows right here C6 and C4. So yeah, we set it up, and then it kind of talks about the trigger modes of the scope, and here's the specs. So you know, that's probably worth taking a quick look at. So the specs, it's a 200 kilohertz scope, what they claim, and sensitivity range is 10 millivolts per division to 5 volts per division, 50 volts peak max, and that's with this 1X probe. So I guess we could probably use a normal scope probe with ×10 and increase that range. Okay, so then it's 1 megohm input impedance, 20 picofarad capped. It says 12 bits resolution. That seems interesting because most of our scopes here have 8 bits, 12 bits. So I'm not sure if that's real. That might be, I don't know. Anyway, plus the size of the display, I'm not sure how meaningful that is, but record length is 1024 points. The time base is 500 seconds to 10 microseconds. Trigger mode is auto, normal, and single. Trigger position, range 50%. Not sure what that means. 50% range of the display or the signal. Power supply is 9 volt, 8 to 12 volt, 120 milliamps. And then the size of it. Okay, so the second page is really cool because it's a schematic. That's way cool. It's broken up into sections. The input section here, where your scope probe ties in, takes you through the signal to the microprocessor in this section. The LCD module connector in this connection, I guess there's 3 actually, 2 little ones and 1 big one. And then a SWD port. Okay. Use for debug mode. Okay, so that's, I guess if you debug it, it probably gives them signals or something. And then your press buttons. And then the UART section, USB and UART. So there is that little mini USB port on this thing. And it's neat because it talks about all the connectors. Here's the power supply section. It brings in that voltage and goes to a 5 volt regulator, and then a 3.3 volt regulator, and then they create a -5 volt with this little switching guy. That's kind of interesting. So they create a -5 volt here. They probably needed to get that for these op amps, for these to have a plus/minus voltage rail. Here, let's just zoom in and look at this input section a little bit closer. Okay, so you can see the BNC comes in. The coupling switch has 3 positions. DC is on top, just comes straight through. And then AC has a capacitor coupling, 0.1 microfarad, and then a ground position, just ties it to ground. And this looks like an unused op amp. It's a TL084 that they've got in here. So they're using 3 of them. They have an unused one. Okay, so then the next thing is the Sense 1 range, and you can go from 10 millivolt, 0.1, and 1 volt, and they show the actual circuits that it's going through for each one of those. Oh, and here's the C4, C6 trim capacitors for the calibration. Okay. So you can see we have to be at 0.1 or 1 volt to use those, and the 10 millivolt doesn't have one, just comes straight through. Sense 2 has 3 positions. They call it X1, X2, and X5, and that's a voltage divider. So signal comes in through the top one that goes right through for X1, or it divides it down to X2, or divides it again for X5. Then goes to another op amp. So the first stage is just a buffer. next stage has some gain, and then it goes in the microprocessor. But now there's another one where it taps off and comes down, and this is for the trigger. So that's pretty cool. It's pretty cool to see the schematic. All right, and then here's the user manual. It looks like you can buy this as a kit where you build it. They talk about that, but it's neat that they show each one of these individual sections so you can kind of know what the connectors look like and so on. But the other side is more the same, but what's really neat is this section here. It has a test section in case you're troubleshooting. Hopefully we don't have to do that, but that's pretty cool. And then of course you can see the board with the LCD removed. Alright, so let's get to the unit itself. We'll zoom in on this guy. Hey, by the way, I'm going to bring this function generator over here and just tie it to the our scope probe. Our ×1 scope probe. Okay, so we're going to just zoom in. Oh, and I've got this little power supply, 9 volt. We're going to plug that in here. And you know what? What I'm going to do is I'm going to plug this guy into power, and then I'll plug this in so we can watch it power up. Alright, so here we go. Wow, that was fast. Well, I guess it's still booting. Okay. Alright. Seems to be boot. Well, small unit, I guess. There's not a lot of memory or anything going on, but that was pretty fast. Alright, so it has these two things here on the in the manual. It talks about how you can turn these measurement things on and off on the screen. So now you see a little box around this 0.2 milliseconds. Alright, so here's the select. That is the trigger mode, auto, normal, or single. Then that's the trigger slope, rising or falling. Whoops. Okay, and then it goes up to the trigger level indicator. Now it goes up to the horizontal position. Then one more push brought us over here to the vertical position. And then back to the time base. Okay, so this right here is the vertical sensitivity. So that's this guy, right? Well, that's this guy. So it's set at 1 volt right now. Then it's 0.1 and 10 millivolts. So, yep, 0.1, 10 millivolts. Thinks it's trying to read something, but there's just nothing there. But that's just sensitivity, I guess. Okay, sensitivity 2 is X1. Oh, there we go. So it does change that. That's cool. So it goes 2 volt, then 5 volt per division. Oh, that's cool. Okay, this one's for coupling. We're AC coupled. You can see that. DC and ground. So we'll go to DC. Okay, 0.2 milliseconds. Okay, I was just looking. I see this number up here in the corner. It's kind of purple. I think that's the trigger position. Let's move back over to that. Okay, I'll use a plus to bring it up. It says negative 0.12. Okay, there's 0. Yeah, that's what that is. Okay, there's plus 0.12. I'll just leave it there. Oh, let's calibrate the probe. Let's see how that's done. Okay, so reading the instructions says sense 1 is in the 0.1 volt position. Sense 2 is in the X5, and set coupling switch to AC or DC. It doesn't matter, so I'm going to leave it on DC. Adjust time base for 0.2 milliseconds, and we just happen to be there. I guess that was the default. Okay, and so then I touch here. I got to disconnect from my function generator. Okay, now I don't need to use a minus probe, and there's this connector up here, but I don't have any pins on it, so I guess I'll just touch it there. Okay, there's the square wave. Let's see, I need to move it down, so let me come over to this position thing. Okay, there we go. It's highlighted blue. We'll just hold that down. Okay. Yeah, it goes faster once after waits a moment. Okay, so here, let me turn off these numbers so we can see that wave shape better. Okay, so to turn off these things, what we do is move this over to the time base right here, and then hold it down for 2 seconds, and it turns them off. Okay, now there's another thing we want to do in this pro tips. I just took a quick read of these. The first one is alignment. So what that does is, I guess it's the trace can be out of line with the position indicator here. It looks like it's dead on to me, but let's just do it anyway. You put the position, the coupling in ground, and then you select the this position here, the vertical position. Okay, and then you hold this thing down for 2 seconds, and it kind of highlighted the line. I guess it's done, but it looked like it might have moved it just a skosh. So, all right. So now I guess we're ready to go back to calibration. Let's go back to DC on this. Okay, so it looks maybe slightly rounded. It says it could be slightly rounded, or there could be this little spiky thing, and you want it square. So it's similar to a normal thing, and that's so the first one we're set up to do is this C4. Let's see if I can find the screwer. There we go. Okay, gotta hold this down. Oh yeah, there's a spike. Okay, I just moved it until the spike just kind of disappeared. So I think that's about as square as it's going to get. Now let's do the other adjustment. Okay, the next one, sensitivity 1 is in 1 volt position, and sensitivity 2 is in X1, and then we adjust C6. Yeah, it looks pretty darn good to me. It might be a touch of a spike, so okay, there's a little bit more spike. Wow, I think that's a 1-turn pot. I went all the way around, so okay. It didn't really get round, it just has a spike, so let's make that as minimal as we can. Okay, that looks pretty good, I guess. Alright, hook up the function generator, and I'm going to start with 1 kilohertz. Hey, you know what we'll do is, what we're going to do, since my generator, since this is only 200 kilohertz, I can easily check the bandwidth, right? Let's do that. Okay, let's turn on the output. Alright, generator is ready to go. I'm going to turn it on, but I think we're going to want to move this up into the center of the screen, and let me see. Okay. That looks like about center, I guess. Now it looks to me like it's offset just a touch. I'm going to put this over on ground and hold this down. Yeah, it popped it right up. So maybe you have to do that occasionally. Or maybe, oh, you know what? Maybe each time you set, change the sensitivity. It looks like each time you set one of these, it changes it a little bit. So, alright, so you might want to, whenever you change the sensitivity to realign it. Okay? It's not a big deal, it's pretty easy. Okay, we need that measurement thing back up. So we need to go to here and then hold it down. And then this pops up. Alright, let's turn on the signal. Okay, where's the signal? Oh, I'm on ground. Alright, there we go. Okay, it says 1 kilohertz. Cycles about 1 millisecond, 0.999 or 1 millisecond. Pulse width is about 50%. Duty cycle is about 50%. Or I mean, pulse width 50, about 0.5 milliseconds. That's kind of jumping ahead to duty cycle. Vmax is 1.5. Minus Vmin is 1.5. Vaverage is 0 because it's an AC waveform. And VPP is 2.9 volts. And volts RMS is 1 volt. So that's why I'm putting out 1 volt, because I wanted to use that to check the bandwidth. So let's start bringing the frequency up. So what we're looking for is when that drops to 0.707, I guess, but I think 0.7 will be close enough. Here, let me go to time base again and change that so we can watch the signal. Okay, the trigger's kind of moving around. I'm going to see if I can lock in a little bit better. I've selected this little arrow. Oh, by the way, I think if I hold this down, it'll auto zero. No, it just, oh yeah, because it's trying to move it. If I hold the select down, yep, hold it down for 2 seconds, puts it at 0, but this thing's kind of jumping around a little bit. Here, let me move it down. Okay, move it down a little bit. Oh, there we go. Now we're locked in. Alright, I'll bring the frequency up a little higher. We're at 20 kilohertz. And I'm at 27. This thing says 27, so it seems to be doing a pretty good job. Whoops. Let's get back to that so I can spread it out. Alright. Okay, I'm 80 kilohertz. I'm at 100 kilohertz. And this says 100 kilohertz. I'm still at 1 volt. Okay, I'm gonna, looks like the trigger's not real sharp, but I'm not gonna try to re-trigger every time. I'm gonna just bring it up until we see that 0.7 volt thing. Okay, we're at 200K. Whoa. I was not watching. I was looking at my generator, and we certainly... Okay, 10 microseconds is... Okay, so yeah, this is not a 200 kilohertz bandwidth. Okay, let me drop it down. Okay, now that looks better. We're at about 130 kilohertz. Wow. About 130 kilohertz is where it starts to look better. It's about 0.9. It's about 0.72 at 170K. Alright, but you know what? That waveform looks kind of screwy, right? So, down to... Here, let's go slow. Okay, that's 50 hertz. Alright. It's 1 volt, so yeah, so at the low end it seems to be doing fine. But it rounded off a little bit before 200 kilohertz. Hey, by the way, you see the green flashing light? That's the triggered. So it shows it's the auto trigger's working. Alright, that's cool. And yeah, we have these little connectors down here that are showing the schematic. Power supply sections up here. You can use either one of these two connectors for the input voltage. Hey, let's do a DC offset with the sine wave. Alright, so I got a 1 volt DC offset, but I'm AC coupled. That's DC couple. Okay, volt average is about 1 volt right now. So that's about right because the AC average goes to 0 and we have 1 volt DC. The max is 2.57. RMS is 1.4. Voltage peak to peak is 3 volts. Okay, it says 50 hertz, and you know, it looks like all this information looks correct. I was kind of expecting the scale, the bottom of these waveforms, to be right across, you know, there. But that was 1 volt RMS, so it's actually 1.4 volts peak, right? So that's why it's a little bit below the line. So yeah, it looks like everything makes sense. Looks like it's doing a good job there. You know, the display seems to be nice and crisp, right? It's not super bright though. Okay, so just for fun, I put this in 10 millivolt scale, and I put a 10 millivolt signal instead, a small signal, and then I took it to 130 kilohertz to get 7 millivolts. I just wanted to see if the different range give it, you know, maybe performed better as far as bandwidth, but it's similar. It's about 130 kilohertz. So as soon as I drop it down, so we're 10 millivolts, so it seems to read the voltage, you know, properly as long as you're down in the lower frequency range. You know, it seems to give pretty decent measurements under 120K. Now, the thing is though, is it does start to roll off a little bit earlier at the low voltage input, because to get 10 millivolts I have to drop to see, right around 13 kilohertz is starting to roll off just a touch. See, it's 9 millivolts. Alright, yeah, so at 10 millivolts it did seem to start to roll off just a little bit at about 13K. It dropped to 9 millivolts. Around 120K it drops to 0.7. Or I mean 7 millivolts. So that's kind of the bandwidth at 10 millivolts is 120 kilohertz. Alright, so here let's just hit a square wave into it. And there's a square wave at 13 kilohertz. So here, let me bring the frequency up. Okay, we're at 10, so I'm at 33K, and it's starting to get deformed a little bit, so about 50K, 53K. Okay, so at about 50K, it's starting to kind of look square, and this says 50K, 50%. So now I'm putting out 14 millivolts RMS, and this seems telling me 12. So at this low end, it seems like the bandwidth starts to roll off a little bit sooner. Here, let's put in 1 volt. Okay, there's 1 volt RMS. You know, I think as far as playing with these, trying to get, there's practically 9 different, you know, sensitivity levels you can get moving these around, I think. So, but it seems like it works better to set this one first and then set this one. Okay, so let's go up in frequency. Okay, we're at 50 kilohertz. Yeah, it's starting to round off. It's about the same thing. That's 60 and that's 50. So at 50 kilohertz, you still get a square wave. Now the edges are much sharper than, the frequency, so it's, that would explain that. It's approximately a 4x thing, I think. What the bandwidth is for a square wave. That's not surprising that we're limited to around 50 kilohertz. Now if I drop down to 40, it's probably going to look a lot better. 30, there's 20, there's 10 kilohertz. Alright, well that looks pretty good. It's not bad. I mean, hey, for under 20 bucks, this seems to be doing fairly well. I mean, we can't really compare it to the precision of the bench scopes. Cost 10x price of this thing at least. But yeah, for under 20 bucks, this thing might be worth having on the bench. It basically, and one way to look at it is it's a lot cheaper than having a differential probe. So if you need to take a measurement and your scope is grounded to your circuit in one spot and you want to, maybe put this right across a resistor or capacitor or something somewhere in your circuit, then, you can kind of use this as a differential probe in a way. As long as your frequencies are, down in the range where this thing will work. So, all right, well that's our first go. We'll use this in other tests on the bench, so we'll get a better feeling for things. But yeah, I think this screen looks pretty good. I have all these bright lights on it, but let me turn the lights away. So yeah, I think the screen looks, pretty decent. It's pretty sharp. I don't know if there's a brightness setting. I haven't been able to find one of those. And the board construction, the quality of the solder jobs and everything look pretty decent. So yeah, it's obviously single side, everything's on the other side, but the silk screen on both sides seems very readable. I could pop off the display, show you underneath. Let me do that. Connectors are pretty stiff. Alright, so that's what it looks like without. There's a microprocessor and there's a crystal oscillator. That is probably the TL082, yep it is, or 84 op amp. So the input circuitry coming in and feeding right into the microprocessor, and then from there right to the display. The display is single sided as well. Just that's the only thing on it, is just display. Now when you line these up, want to be careful. And the other thing, whenever you're pushing something down with a glass display, you want to put even pressure. If you torque the board, you can break the glass. I worked at a defense contractor years ago where we had really expensive displays where the glass is just stacked up on top, layers of glass. And this guy that was installing these things, and it kind of put a little bit too much torque and a big old crack right down the middle. That was a $20,000 display. Did it twice. That did not go well. Alright, so let's do a real world test. Let's turn this guy back on, and we're going to turn on my lab power supply. Let's turn on my bench power supply, and we're going to run power into this buck converter, and we're going to watch the output. Oh, sorry, this is a boost. So the way the boost works is we bring the voltage up, you'll see the voltage increase on the screen, and then when it starts to boost, you'll see it jump. And this thing should put out about 19 volts. I think it's just barely over 19. Okay, Okay, you know what? I'll zoom in a little bit closer to the board. Okay, we're going to be looking at about, let's put 5 volts per division. And I'm going to go back to this ground and so I have to move this over here. I'm going to zero it out, hold that down for 2 seconds. I don't know if you saw that, but it moved just slightly. Alrighty, so let's see what we see. Now this time base, we'll go a little faster since it's power supply. See high frequency ripple, and I'm going to move this down. Just gotta hold down. Okay, then it starts speeding through. That's faster than just. Okay, so I've got this thing down here. It's all set up. We're at 5 volts per division. Got this on X5. Set that for 1 volt, and we're set on DC. Okay, so I'm going to start bringing the voltage up. About 5 volts. This says about, yeah, 5.43. Okay, pretty soon this thing's going to just take a jump up when it starts to boost. Yep, right there. You saw that jump? So my input's 12 volts and I'm reading 19.7 volts. I can see a little bit of ripple up there, but I think that ripple is high frequency. This guy's switching at a pretty high frequency, so you know, I'm sure over 100 kilohertz. So this meter, this little scope, it's going to show a little of something, but it's not going to be able to show that. Yeah, it seems like a useful tool for under 20 bucks. You know, I'm actually kind of impressed. I mean, it's got a nice display. It's a little bit easier to see or read than I thought I'd be able to see on a little display like this, but not too bad. There's a close-up if I can hold steady. Hey guys, so okay, I have to admit that I was a little nervous testing something that somebody gave me because I didn't really want to give a bad review, but I have to tell you that for, you know, under 20 bucks, 18, 19 bucks, whatever this thing costs, that's fairly impressive, right? I mean, look at that thing. Yeah, I gotta give it a thumbs up. I think this guy is worth it. What do you guys think? I'd like to know what you guys think. Maybe, I hope I'm not being swayed by being given a $20 gift. But anyway, I do think that I am actually impressed. So, yep, I think it deserves a thumbs up. So thanks Gearbest for sending this, and anybody that is interested, I appreciate it if you hit the little link below and go to Gearbest and check them out. I guess maybe I should have bought something from Gearbest. You know, tested that, see how that went. But I guess with one purchase you really can't tell, can you? So anyway, alright, hopefully didn't go too long on this video, and still think that's pretty cool. Hey, thanks for watching guys, and let me know. I really want you to know your honest opinions on this guy, and if anybody's ever used one, it'd be really cool to know what you think. Yeah, pretty cool, huh? Alright guys, give me a thumbs up if you like that. Give Gearbest a thumbs up. If this works out well for them, then they're going to send me things that I can give away. So that'd be kind of cool too. Alright, I'm dragging this on. Thanks guys for watching.